Dear students, welcome to s.mathguru classes. Today we shall start the differential equation of first order differential equation. These are important for any engineering courses. It may be in first semester, second or third semester, but these are important. So the conception of differential equation, what is differential equation, what is order, what is degree, it was given. You can see the playlist and it was given. Now we start from variable separable. Differential equation of first order, first we consider variable separable. If a differential equation can be written in the form f of y dy, phi of x dx, we say that the variables are separable. Y on left hand side and x on right hand side. We get the solution by integrating both sides. After separating, if we integrate both sides, then we get the solution of the differential equation in case of variable separable. How to solve variable separable? Some working rules you have to maintain. Step 1, working rule, step 1, separate the variables as fy dy, phi x dx. We separate dx with y, dy with y, dx with x. We separate in this way. If xy mix up, then we separate this. We write dy with y, dx with x. After separating, integrate both sides as integration fy dy, integration phi x dx. After getting the result, add step 3, add on arbitrary constant c on right hand side. These three conditions you have to maintain. First is separate xy variable, dx with x, dy with y. We write in this way, and after separating, integrating both sides, and after getting the result, we adding a c, arbitrary constant c. These are the working rule. Let us consider one problem. The problem is that solve x dy plus y dx equal to 0. Suppose this problem is given x dy y dx equal to 0. This problem given. Now in this problem we know dy with y, dx with x. Here we get dy with x, dx with y. These are problem. Which are the main factor? X and y. These are the most criminal. We divide both sides by this. If we dividing both sides by x, y, because here must be y, here must be x, but their position is different, we divide both sides by x, y. If we divide both sides by x, y, we get this. This is dy by y, this is dx by x equal to 0. So separable, variable separable is complete. Y with dy with y, dx with x. Now we integrate this. If we integrate both sides, we get this one. This will be log y plus log x, and we consider log c also, log c. In case of logarithm, if plus given, we write into yx equal to log c. Then yx equal to c. And this our answer. Answer is yx equal to c. This is the final answer. Very easy solution. Very interesting also. Just which are the main factor? X and y is the main factor, because here must be y, here must be x. So we divide both sides by x, so we get the result. Now let us consider another problem. Dy dx equal to, solve dy dx equal to x, y log x plus 1, sin y, y cos y. These are problem. Now solution is start. We multiplying this on left hand side, this one on right hand side. We get, first we rewriting this dy dx equal to x to log x plus 1 by sine y plus y cos y, and variable separable sine y plus y cos y dy, x multiplying this 2x log x plus x dx, this dy into this, dx into this. So already variable separation complete, because this is dy, all of these are y, this is dx, all of these are x, no problem. So we can easily integrate. Now integrate this, if we integrate we get sine y, y cos y, we integrate both sides, twice x log x plus x dx. Now this will be integration sine y dy plus y cos y dy to constant x log x dx plus x dx. We get this. Here we using bypass formula. This is bypass formula, product of two function using bypass formula. Now we know the bypass formula, integration fx into gx into dx equal to fx integration gx dx minus integration ddx of fx integration gx dx into dx. This one we get. Product of two function, first function integration second function integration ddx of first integration second dx dx, we get this. But here which one we consider fx, which one we consider gx? Now we know the islet, this condition. In case of islet, here we have algebraic and trigonometry. Algebraic first, trigonometry second. So this is inverse, logarithmic, algebraic, trigonometry, exponential. So we have here algebraic and trigonometry. So algebraic first, trigonometry second. But here we get algebraic and logarithm. Logarithm first, algebraic second. So here we consider algebraic first, this is second. Here we consider logarithm first, this one second. Now this will be integration sine y means minus cos y, and this is bypass formula, y integration cos y dy minus integration d dy of cos y integration cos y dy into dy, this one. This is minus cos y, this is y integration cos y dy, and this one d dx using this formula d dy of cos y dy. And right hand side 2 is common, again using bypass formula. Here logarithm and algebraic, logarithm first, algebraic second. So I consider this is fx, this is gx. So this will be log x integration x dx minus integration ddx of log x integration x dx into dx, we get this. And the last one is integration x means x square by 2, we get this one. Now this will be minus cos y integration cos y means sine y dy 1, this is sine y dy, this is sine y, this is dy, this is 2 log x, and this will be x square by 2, and these 2 multiplying here, ddx of log x means 1 by x, this is x square by 2 dx plus x square by 2 we get. and this will be minus cos y, y sin y. Integration sin y means minus cos y. This equal to 2 cancel x square log x. This 2 cancel, 1 x also cancel, x dx plus x square by 2. We get this. And this will be minus minus plus, plus cos y minus cos y, this will be cancelled, and we get y sin y, this equal to x square log x minus x square by 2 plus x square by 2, and this 2 will be cancelled. Finally we get y sin y equal to x square log x plus c, and this is our final answer. So answer is y sin y x square log x plus c. This is the answer. Very nice solution, very easy solution. This is very interesting. Consider this problem. Solve the differential equation x to the power 4 dy dx plus x cube y equal to minus sec of xy. But here no problem. This is the problem, xy within sec. This is not possible to separate. At that time we consider xy equal to another variable. Solution: let xy equal to z. If we differentiating both sides with respect to x, we get this one. And this is product of two functions. First function ddx of second, second function ddx of first, dz dx, x dy dx, y dx dx 1, we write this dz dx, we get this. Now we consider our main equation. Now x to the power 4 dy dx plus x cube y equal to minus sec of xy. This is our given equation. Now from these two, taking x cube common, from these two x cube common, we get x dy dx plus y minus sec of xy. X cube, x dy dx plus y, this value is dz dx, dz dx, and this is sec z. Xy initially considered that, so xy equal to z, and this value we get dz dx. Now dz by sec z dividing this side, and this one minus dx by x cube. Just separate this, sec x dividing this side, this one we divide this side, and dx is here, we get this. Now we integrate both sides. 1 by sec means cos z dz, and minus dx by x cube. So we get this, but integration cos z means sin z, and this will be minus 1 by 2 x square, because plus c, because we know this formula, integration dx by x to the power m, this is minus 1 by m minus 1 x to the power m minus 1 plus c. We know this formula. Dx by x to the power m means minus 1 by m minus 1 x to the power m minus 1. So here m means 3, minus 3 minus 1 is 2, 3 minus 1 2. We get this, and this will be sin z. Z means xy. equal to 1 by 2x square plus c. So this line is clear. If this line is clear, then this is our answer. Not clear, then also answer. This is the final answer. Very nice solution. These are variable separable. Consider this problem. Solve cos of x plus y dy equal to dx. This problem is given. Now solution. So this problem we can write dy dx equal to 1 by cos of x plus y. Dx taking this side, this one on right hand side. So we get this one. Now this is not possible to separate x plus y with cos. They are not possible to separate. At that time we consider another variable. This equal to we consider z. Differentiating both sides with respect to x, then we get this one. This is 1, this is dy dx, and this is dz dx. So this implies dy dx equal to dz by dx minus 1. We get this. Now this is number 1 we consider. Now 1 implies putting the value in 1, dy dx we get dz by dx minus 1, and this is 1 by cos z, we get this, and taking dz dx, and this will be 1 plus 1 by cos z, we get this, and this is dz by dx cos z LCM cos z plus 1. Now we separate this. If we separate the variable dx multiplying this side, this one on right hand side, cos z by cos z plus 1 dz equal to dx, we get this. Cos z this side, this one dividing this side, and dx on right hand side multiplying. Now we integrate this. If we integrate, we get this, and here we get cos z, this like power, we write cos z plus 1 minus 1 by cos z plus 1 dz, this is x we get. Integration dx means x. Now if we separate this by this, 1 by this, so this by this is 1, and this is 1 by cos z plus 1 dz equal to x, we get this one. But we know this formula, cos twice a equal to 2 cos square a minus 1. We know this formula from lower class. And if we write cos a, then in half angle cos square a by 2 minus 1. 1 taking left hand side, 1 plus cos a equal to 2 cos square a by 2. So if we taking 1 left hand side, then we get 2 cos square a by 2. So we get, this is integration 1 dz, and this one dz by 1 plus cos a, 1 plus cos z means 2 cos square z by 2 equal to x we get. And this one z, 1 by 2 remains same, 1 by cos means sec square 1 by 2 z dz x. Again you know this formula, integration sec square mx dx equal to 10 mx by m plus c. So this will be z 1 by 2 tan mx by m. M means half. Sec square mx dx means tan mx by m. So m is half tan mx by m, mz by m. X plus c, and z half cancel, minus tan 1 by 2 z x plus c, and z means what? X plus y. X plus y tan 1 by 2 x plus y equal to x plus c, and this x cancel, and this implies y equal to tan of 1 by 2 x plus y plus c, and this is our answer. Very nice solution. Y equal to tan of 1 by 2 x plus y plus c. Very easy, very interesting also. The simple calculation. Consider another interesting problem. Dy dx equal to 4x plus y plus 1 whole square. If these are mixed up, then we consider another variable. So let 4x plus y plus 1 equal to z. If we differentiating both sides with respect to x, so what we get? This 4 into 1 dy dx plus 0 dz dx, and this implies dy dx equal to dz dx minus 4. We get this one, and putting the value here, we consider now we putting here value. This value is dz dx minus 4, and this value we consider z square, dz dx and 4 plus z square. Now variable separation, here z square, here z, so this is taking this side, this one on right hand side, dz by 4 plus z square equal to dx. We get this. Now we integrate both sides. Dz by 4 means 2 square, z square remains same, this is dx. But you know this formula, integration dx by a square plus x square equal to 1 by a tan inverse x by a plus c. So this is dx by a square plus x square equal to 1 by a tan inverse x by a plus c. So this is a square plus x square formula. So this implies we get 1 by 2, 1 by a, that means tan inverse z by 2, and dx means x plus c. We get this one, and we consider c1 first, and multiplying both sides by 2, then we get tan inverse z by 2, this is twice x plus 2c1, and putting the value of z means 4x plus y plus 1, 4x plus y plus 1 by 2 equal to twice x plus c, where capital C equal to 2c1. This is the final answer, and this is the required answer. So answer is tan inverse 4x plus y plus 1 by 2 twice x plus c. So dear students, these are very nice solution, very interesting high secondary level problem, but these are important for engineering. At the very beginning, if differential equation given, this is the starting problem, these are the starting problems. So you have to practice this problem, and without practice mathematics is difficult, with practice mathematics is nothing. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.